Hey there, so I'm doing example 8 here. Which of the following sets of ordered pairs defines a function? So a function, one of the tips, like I said, to do this question, remember a function is when an x value goes in that you only get one y value out. Now you can have multiple x values, but it has to be the same y value, right? So we want only one y value when an x coordinate comes out. Best way to see this, or a trick to it, is check if there are repeated x values. So I simply look at A, I look at it and then say, oh, there's -3, -1, -6, 1. They're all different. Okay, they're all different. So that's okay. That tells me that there are no x values like repeating, meaning there isn't a second one to give me another, I don't know, like 2 x's to give me 2 different y values. Okay, so 2 of the same x values to give me, so saying, what I'm trying to say is, essentially if I sub in x equals x1, I don't get 2 different y values. That's what I'm looking for. So I want to see, will I get 2 coordinates with the same x value? And I don't see it there. So here's an example. If we were to quickly plot this, -3, -4, is somewhere here, so this is a point there, -1, -1, say here, -6, 7, so -6 and then 7, it's up here, and then 1, 5. So you can see that every coordinate, if I drew a vertical line down them, I don't get any 2 intersections, I only get 1. So that's one way, so you can draw it to visualize it, or you can do my technique, which is to double check if there's any repeating x values. Okay, so that's what I would say to make it easier for you to sort of find. I don't know why I can't move this actually. All right, there we go. Okay, so I would say which of the following sets defines a function? I would say A is a function. Whereas if I look at B, you see there's -4 and then -4 again, and then -6 and -6 again. So if we were to quickly plot this, okay, you will see my point. When x is -4, the y value can be 1, so it's over here, or it can also be -1, which is here. And that's a problem already, okay? Can you see the problem? Whereas the other one, when it's -6, is going to be 7 and 8. So say 7 is up here and 8's up here. Then you get these 2 points. What I'm trying to say here, this is a problem because if you substitute a -4 in, right, you can either get -4, 1, so it can come out as a 1 value, sorry, a 1, or it can also come out as a -1. Can you see that? So for one x value, I get 2 y values. That's not the definition of a function. A function says it has to have only one unique corresponding y value. That's why I know this is a relation and not a function. A way to know, you can also do a vertical line test. So that's why if I drew a vertical line down, you can see I cross at -4 twice. Okay, they have that -4, -4. That's why I'm saying if it repeats the x values, that's a quick way of knowing whether it's a function or not. And same thing again, if I did a vertical line test here, crosses twice, again, they've got 2 x values, which is -6. So that's why it's a relation. Okay, so that's question example 8 there. You can have a look at same thing with example 9, quite similarly in the same idea. Is y equals x squared a function? State the maximal domain and range of y equals x squared. So here they want you to sketch the graph, well, you don't have to, but I'm sketching it for you to visualize. You can see here that if I were to sketch a x squared graph, we know it looks like this. This is what a parabolic shape looks like, okay? Now, is this a function? Well, you can do a vertical line test if you like, if you prefer using that, or you can just kind of look at it and you can see that for every x value, there is only one y value that's corresponding to it. See that? So x2 gives you y2, and then, so I would say, I don't see anywhere on the graph where there's a repeating x coordinate and you get 2 different y values. So yes, this would be a function, or you can do a vertical line test. Doesn't matter where you draw the vertical line, it crosses only once. And so therefore, this is a function. So first part of A, yes, it is a function. Okay. Now they say state the maximal domain and range of the function. So I'm going to rub this out just for you to visualize. Ooh, too much there. And maybe I'll just keep... Wow, that's so hard. There you go. Okay, so... Oh, wow. Oh, wow. Maybe I'll just leave it. Okay. Now, if you look at this... if you look at this graph here, can you see that the graph has infinite x values that it can take? It can go from negative infinity to positive infinity. So we're just looking at domain and range. So its maximal domain clearly is x is an element of any number. So R. So that's saying that it can be any value, because it doesn't matter where you draw. It doesn't seem like there's anywhere on this graph there's always an x value that it can have, meaning that if you selected one, you can draw it. It will be on the graph and it can be drawn onto the x-axis. Okay, so x seems like it can take every value, whereas y, as an example, y can't take every value. You see, that's the vertical expansion. It goes all the way to negative and goes all the way positive infinity, right? But can you see that there's nothing in the negative region for the y value? The graph doesn't exist there. The graph is drawn in green and you don't see any coordinates there. So that means there is a limitation to the range. The range, the smallest value it can take clearly is right at 0. And then it can take any single value all the way to positive infinity. Okay, and you have to remember, looking at the domain and range, you have to focus on either the y-axis or the x-axis. Okay, so for the range, it's the vertical. For the domain, it's the horizontal line. Okay, and I can see that it can only then take positive y values, and therefore my range starts off at 0 and it goes to positive infinity. Okay, if you remember to use an open bracket. Alternatively, there is also another way of writing this. You can also say y is an element of R positive, meaning that every number that's positive, but remember that doesn't include 0, so you have to then say union and you list the 0 using braces. Okay, so that would also mean the same thing, 0 to infinity. So it's up to you whether you want to use interval notation above or whether you want to use set notation below. Okay. But that's how you would answer A for the maximal domain and the maximal range. And they say is x squared plus y squared equals for a function. This, you would have to type it in your CAS to find out what it is. That's a circle with radius 2. Okay, so if I were to sketch it for you, we go to, where's menu? Go to menu, graph, entry, and we can go to relation, and menu, circle, and yeah, would I do a standard form? No, I'll do this one. So x, it's a bit hard because I've never taught you how this works, but essentially that is x squared plus y squared equals 4, and you can see it ends up being a circle. Okay, I'm just wondering if I could do it without the template. Let's go back to menu, graph entry, and just go back to relation. If I said x squared plus y squared is equal to 4, yeah. So you could have just typed the equation down and then it'll do the relation, and you can see it's a circle. Okay, I'm just gonna clear out all my other equations. Oh, and then the function, where's the function? Graph entry function, delete. Okay, well, sorry, I'm now just messing around, aren't I? I'm just trying to delete these. There has to be a quicker way to do all this. All right, there you go. So that's your circle function right there. X squared plus y squared gives you equals 4 is a circle. So is this a function? No, if you did a vertical line test, you can clearly tell that's not going to be a function, it's a relation. But what is its maximal domain and range? Clearly, you need to know what the x-axis is and the y-axis is, or intercepts. And I know this is going to be a radius of 2. So it's going from -2 to 2 for your x domain. And then your range is also from -2 to 2 is how you would do this. But look, you haven't learned circles, and you won't need to learn circles as part of the curriculum anymore. So you can ignore B.